You would think that a form is really a container for controls, and really it is, but that's not quite right. In .NET, the system.windows.forms.form class inherits from the system.windows.forms.control class, which means it has a property which can contain controls, but it itself is just a special case of the control class. If you look in the .NET Framework documentation, you'll find this hierarchy of controls. As you can see, the system.windows.forms.form does inherit from system.windows.forms.control through the scrollable control, which is a parent for the container control, which is a parent for the form class. So a form is just a special case of a standard control. It's scrollable. It's a container for other controls. Which means, my point here, is that the events of a form are very similar to the events of a standard control. Each control can add its own events, just as a form does, but there are many events that they share. .NET developers focus on learning about classes in the .NET Framework. You can't learn them all, but you need to find out what you need, that it is at any point what you need to know is where you go research to find out specific behaviors of a particular class. Windows developers, in addition to learning the framework, have to also learn about form and control event models. We'll start by looking at events of forms. I'll click Explore Form Events, and this form has been hooked up already with event handlers to tell information about the form. So for example, here, before I've done anything with the form, its move, load, and activated events occurred. If I move the form, you can see its move event occurs again. If I click off the form and then click onto the form again, you can see its deactivate and activated events occur. How is that hooked up? Well, let's just go see what's going on within this form. Let's shut down our application and go to Form Events here and look at the code. Here within the form, we have, for example, a clear items procedure which will clear everything from the list box on the form. We have a display item procedure which will insert into the 0th location in the items collection of the list box whatever text you supply. We have another overloaded version which allows you to supply a template for the information you want to supply, and another overloaded version with 2 parameters supplied with the template, 3 parameters supplied with the template, and so we have multiple different ways to display an item in the list box. In each case where we have multiple parameters, we call string.format using the template you supply with either 1, 2, or 3 parameters filling in the placeholders in the template. Now you can see here we're reacting to the activated event of the form, the click event of the form, the double click event of the form, the load event, the move event, the resize event, all of the form. And in each case we call display item to display information within the list box on the form. There's also code that reacts to the clear buttons click, the mouse page click, the mouse down of the mouse page. There's a lot of events being trapped here. You can see some of these have templates which will fill in placeholders at runtime with various bits of information supplied to us in the event args parameter. Well, that's really all there is here. There's really not much going on. We can turn on or off the mouse move event handler because the mouse move gets in the way. If we display stuff all the time about mouse moving, it just fills that list box with information. So we only display that if a checkbox is checked. Down here in the mouse move, we have some code that displays where the mouse is. In the key down event handlers, we'll display information about the key codes. And that's about it. We have some validating code we'll look at later on. And I think that is all the interesting code that's in here. Everything else is just displaying information about event handlers. There's a bunch of validation code we'll look at, and that looks about it. So for our form, we should have code that tells us have we resized the form. There we go. Have we moved the form? Have we clicked on the form? And that looks like all we're handling. Okay. Oh, double click, one more. Double click seems to work as well. Let me clear the display and try double click once more. You see, when I double click, we first get a click event and then a double click event. What this means to you is you'll very rarely handle both the click and the double click event of any control, because anytime you do, you get two events, both the click and the double click. So how would you know that there was a double click happening if you're in the click event? That's too confusing. So you generally only handle one or the other of those events. You can trap and react to several different keyboard events. Control and the form class raise three keyboard-related events. There's key press. That's when you press and release a key. There's also key down and key up. That occurs when you press a key down and, obviously, when you let the key go. The key press event handler receives a key press event args object, which provides information like the key char property, so you can know which character you've pressed. The key down and key up event handlers receive a different argument. It's a key event args, and this provides a lot of information about the key pressed, which shift keys were pressed, and more. How do you know when to use each one? Well, if you need information about the letters that the user types, you trap the key press event. You want to know they pressed A and then B and then 3 and then 9. Use key press. If you want to monitor every keystroke, left arrow, right arrow, key going down, key going up, then you need to handle the key up event. Generally, you don't handle both key down and key up unless you want complete control over every aspect of the keyboard. Generally, you can just trap key up. They've let the key go. And you watch out for this, however. The key down event occurs multiple times as the key is held down. That's why you generally don't trap key down unless you also want to know about how long they've held the key and react to those multiple key down events. You only use key down if you want to know about the status of the key, including the fact that it's being held down. Let's talk more about the key press event. The key press event args, which gets handed to you as the second parameter of the key press event, includes two important properties. Handled, so you can set this to true to indicate that you've handled the key and the .NET Framework won't do anything with it. You can then cancel further processing of the key. And also the key char property, which is a char value, that's a data type, char, indicating the key that was pressed. Using this property, you can know exactly which key the user pressed. The key up and key down events are often used to add custom functionality to controls. You can use these events to change keystroke behavior. The sample modifies, in a somewhat clumsy sort of way, the behavior of the up, left, right, and down keys. Let's look at the example of these two events to see how you might use them. On our sample form, I'll click the Keyboard tab, which allows us to try out the various keyboard events. Let me come to this text box and just type a simple S. Well, S right now, it's lowercase. You can see the key code was S because the key down and key up events don't care about what case the letter is. All they know is which key you pressed. I pressed the S key. Its key value is 83, no modifiers, no shift keys, that is. The key press event knows exactly which letter I typed, in this case a lowercase s, and the key up event, again, just sees it as I worked with the S key. Let's try it again. This time, I'll press Control-Alt-Z. You ready? Control-Alt-Z, what does that give us? Well, the key down gives us control. Key value is 17, that's key number 17, and the control key was down. Then when I pressed Alt, Control was already down, now Alt is down, but only the Alt key registered as the key I pressed in the key down event. Then I pressed Z, so this Z key got pressed with a key value of 90, and its modifiers were Control and Alt. Next I get the key up event. Since Control-Alt-Z doesn't display anything in the text box, there's no key press event at all. key up for the Z key, for the Alt key, and finally for the Control key. Notice the Alt key is named Menu. Who knows what historically that's what its name is. In any case, Alt is named Menu in the key down event when you ask it for the name of the key. Let's try one more. I come here and I type backspace. Backspace does have a key press. It is a key character which causes the cursor to go back a letter. You can see that the key value is 8, no modifiers, and the key code is named back. Let's put a few letters in here. And now let's disable the backspace key. We'll see how that's done in just a moment. But if I try to press backspace, the key down and key up occur, but the key press event didn't occur. So we must have code that's somehow absorbing that keystroke, so the key press event never gets registered by the code in this form. Okay, let's go on. We have a text box here in which I can type lowercase letters and have them converted automatically to uppercase letters as I type. I'll type some lowercase letters here. Those were all lowercase letters, and they appear as uppercase here. Notice that if I try to type numbers, I type 1, 2, 3, 4, 5, they just don't appear at all. Down here, I can use the arrow keys. The left and right arrow keys do certain things. The left arrow key moves the date time picker to the first day in the month. The right arrow key moves it to the last day in the month. I told you this is kind of a clumsy demo. Also, the up arrow key moves us up a year, and the down arrow key moves us down. Well, I got two of them in there, but in any case, it moves us up and down a year. Okay, let's see how that's working. That's called a demo flaw, not a bug in Visual Studio. Come to our code here, and for this text box, we're handling the key down, key press, and key up events. Let's see how they work. The key down event, we just display some information. We display here the key value, the modifiers, and the key code. You can see those come to us as properties of that E parameter, which is a key event args object. In the key press event, we get sent a key press event args object, and it doesn't really have too many interesting properties, handled and key care. We'll come back to handled in a minute. And for the key up event handler, we get handed, again, a key event args, so we can display the key code, the key value, and modifiers, information about the key that was pressed or let go. Okay, back on our design surface then. What happens when we disable the backspace key? Let's see what this does. When I disable the backspace key, well, if that's checked, then we'll set this .keyPreview to true. The key preview property of the form indicates that the form should handle key events before any of its corresponding controls. So here we say not only do I want the form to handle this, I want the form's key press event to use this event handler called disable backspace. Of course, if I uncheck it, I do the opposite. What does disable backspace do? Well, it gets sent the same event arguments as any other key press event would, and it checks the key care property of E, and if that is a backspace key, which is character 8, if that's the case, we do nothing at all but indicate that we've handled the character, so that Visual Studio and the .NET Runtime don't attempt to do anything at that point. It does not even attempt to insert the key, just disregards it altogether. We are, in effect, eating the keystroke so that the .NET Runtime never even handles it. Here, when we convert lowercase to uppercase, in this case, we're handling the key press event. The key press event checks to make sure that the character is a letter and also that it's lower or white space, one or the other. If it is a character and also lower or white space, in that case we append text to the key press text box, and the text we append is the key character converted to a string, converted to upper, and we append that text and also indicate that we have handled the keystroke. by telling the .NET Runtime that we've handled it, it won't attempt to append the character in addition to the code we've run to append the character to that text box. Finally, using the arrow keys, here we're handling the keyUp event. And in the keyUp event, we're taking a switch based on the key code. And the key code returns back a value from this keys enumeration. The keys enumeration is an enumeration that has all of the various keys that you might press, like the right key. And if it's the right key, we tell the .NET Runtime that we've handled the keystroke, and we set the date time picker's value to be the last day in the current month. For left, we use the first day in the current month. For up, we just add a year, and for down, we subtract a year. And we're using these helpful procedures, first day in month and last day in month down here, which you can investigate if you like. In any case, the arrow keys now have modified the behavior of this control, and we put this code in the keyUp event handler. You'll find several different events that deal with the mouse, including things like click and double click, mouse enter, mouse leave, mouse down, mouse up. There's mouse move, mouse hover, and there's the mouse wheel event, so you can tell when the user has scrolled the wheel in the middle of their mouse. We'll look at just a few of these. We'll start by looking at the mouse move event. This event occurs obviously when you move the mouse, and it receives a mouse event args parameter, including useful information like button, that is, information about the button that's selected at the same time the mouse is moving, clicks, keeps track of how many clicks there have been, delta is how far it's moved, location is the current location, and an X and Y property so you can retrieve either the X or the Y coordinate individually. The mouse up and mouse down events react to the user pressing and releasing the mouse buttons. If your goal is to determine when the user has clicked on any item, you'll probably want to use that item's click event. On the other hand, to determine exactly where the user clicked, or which button or buttons were selected when the click happened, or how many clicks occurred, you want to use the mouse up event. So the mouse events correspond pretty closely to the key events. To track mouse movement, you want to track the mouse down event, which keeps firing as long as the mouse is down. Let's look at some examples that show off these various events. On our sample form, I'll click the Mouse tab, and now we have the option whether or not to show the mouse move event. Well, certainly if I click, we'll get mouse down, click, and mouse up events. If I move the mouse, I don't get anything because I haven't turned that on yet. I can double click, and you'll see if I double click, I just get multiple up and down and click events. There isn't a double click event for this particular control. Notice that when we get the mouse down and mouse up events, we get the coordinates of the click. And when the mouse leaves the control, we get a mouse leave event. When we enter, we get an enter event and a hover event because we are hovering over this. I'm only trapping one of those. If I clear the display and now show mouse move, stand back, because every time I move the mouse over that, I'm getting a mouse move event, and it shows me the coordinates of where it clicked. What you didn't see, because I quickly removed it, let me show this again, is that when I leave the page and go back to this label control, you'll see that we get a mouse leave event, because we left the page that was trapping the event and moved on to some other control. It's important to note that when you click and let go, you get a mouse down, click, and then mouse up in that order. If all you care about is tracking whether or not the user has clicked on something, just trap the click event. You don't need to care about mouse down and mouse up. On the other hand, if you want to know, let me turn this back on, if you want to know that the user has moved across a surface, although I'm not displaying it, I do have the left mouse button down at this point. I could gather that information in the mouse move to know that the mouse move has occurred and which buttons were selected at that time. Now, under controls, there's a lot of control events here. We can't really talk about all of them. Here you can see selected events and what occurs when you select something. For example, here, if I click on a radio button, we get several different events that occur. the drop-down list. We get enter, and once we choose an item, we get a selected value change, a selected index changed event, and so on. Here in this text box, if we type numbers, you see we get the text changed event, and we'll talk in just a moment about validating data in this text box. We'll come back to that after we've discussed how the validating of user input occurs. One of your jobs as a developer is to ensure that data is correct before you save the data somewhere. Any control that can receive the focus provides a causes validation property. If causes validation is true, as the control receives focus, the control that just lost the focus raises its validating event. If the causes validation property isn't true, the control that just lost the focus doesn't raise its validating event. The validating event receives a cancel event args parameter, and this provides a cancel property. You can set the property to true to cancel the validation of this value. If the validation is canceled, focus returns to the original control. So imagine this is what's happening. You have a text box you're leaving, and you press tab and you go to, say, another text box. If the second text box has its causes validation property set to true, then when you leave the first one's validating event occurs. You can then run some code in the validating event to determine if the data is valid or not. If it is, you just let it go. If it's not, you cancel the validating event, and it will set you back to the original text box. The events occur in this order. There's the enter event of the new control, the leave event of the previous control, the validating event of the previous control, and then the validated event of the previous control. So then it's the validating event where you'll put your validation code. In the validating event, you'll set e.cancel to true to cancel the event. Focus returns to the control that failed validation. If you set e.cancel to false, and that's the default value, you don't have to do that, that's the value it will have, validation completes, and focus moves to the next control, the control the user was trying to move to in the first place. You can't cancel the validated event. You got to add your validation code that might fail in the validating event. The validated event, that is the one that can't be canceled, is available so you can log the validation or take some other action once the validation succeeds. If the validating event fails, the validated event won't occur. Now that's not enough. You also need some way to indicate to the user that the validation failed. And this is where the error provider component comes in. The error provider component, which is invisible at runtime unless some error occurs, makes form validation more intelligible. It provides a user interface indicating controls that haven't validated. You can specify an error description string. If the validation fails, the component displays a flashing icon next to the control whose validation failed. And if you hover the mouse on the icon, you'll display the error text for that error provider. Now, like all invisible components, the error provider resides in the form's tray area. It has a couple of interesting properties, like the blink style. We'll set to blink if different error, so it'll display if the validation fails. There's an icon property, so you can set the icon for the error provider as well. You need to call the setError method of the error provider to specify the error text that should be displayed. The icon won't display unless you pass some text. Otherwise, there really wasn't an error, was there? If you don't supply text, what error was there? Now, you got to remember, the error provider doesn't do anything about the error condition. All it does is simply display an icon with a message. Now, imagine this scenario. Imagine you want to create a cancel button. So imagine you're allowing the user to enter some input. They enter the wrong input. They want to close the form, say. But if you're handling the validating event and you cancel the validation, you put the focus back on that control. They can't close the form. The problem is causing validation can leave users in a situation where they can't enter the correct data, Or perhaps they can't leave the control because the data is invalid. You might want to allow the user to cancel the form even if the user's data is invalid. Why make them enter valid data just to cancel the whole form? So it might be helpful to provide a cancel button on your form. That would set the control to a valid value and then call the set error method of the error provider, specifying no text so the icon goes away. Well, that's a lot of information. Let's look at our demo and see how we implement all those different behaviors. On the sample form, if I attempt to choose a value from this combo box, and this is kind of a dopey example, but it proves a point, if I try to choose bananas and then leave the control, we get an error. Yes, we have no bananas, pick another fruit. At this point, if bananas is selected in that drop-down list, we can't even close the form. If I choose something else, however, sometimes that gets tricky. There we go. Now we can move off of it just fine. And we could close the form. How is that happening? If we look at this form in Design View and look at, let's get some space here. And look at that Controls tab. Here, for this control, in the validating event, we'll find this code. And it says, if the text in the combo box is bananas, then cancel the validation. And remember what that does is that causes it to be impossible to leave this control and also display a message box. Either way, we display information to the list box on the form, but that has nothing to do with the validation of this control. Now here's another example. Here in this text box, we're instructed to only enter numbers. If I attempt to enter something else and attempt to leave, say by clicking this checkbox, we can't. Focus goes back to the text box and this error provider displays. If you look at the designer for this thing, you'll see there's our error provider, and it itself doesn't have very many properties. Right to left change an event and just a few properties here. But if we go look at the code for this thing, here we were in the validating event. You'll see first we declare a float, which will contain our output value. And if the length of the text box is greater than 0 and we're not able to parse the information from the text box into that float, that means we had something in there that was not a number. In that case, we're going to call the set error method of the validation error provider, telling it which control we're validating and the text to be displayed on that error provider. We also cancel the validation, so we can't leave the control. So again, it works like this. If I enter a good value, we're able to parse it just fine, and we can leave just fine. If we can't parse the value, and we attempt to leave, at that point we cancel the validation and tell the error provider what text to display. We can't close the form at this point. I can try, but I can't. If I do that, now I can close the form just fine. Well, how about that cancel button? What does it do? If I type 1, 2, 3, 4, cancel doesn't do anything, it just clears it out. If I type 1, 2, 3, 4, Q and click cancel, it takes care of the situation. Watch what happens if I don't click cancel. I come here, I got an error, of course. If I now click cancel, it takes care of the situation. What did that cancel button do? Let's go back to the designer and see. In the cancel button's click event handler, all we're doing is setting the text property of the text box that had the bad value in it. We're setting it to be an empty string. And we also need to call the set error method of the error provider, telling it which text box we're validating and what to display. Since we've set the value to be displayed in the error provider to be an empty string, it knows just to reset itself. So by doing that, we've reset the error provider and we've cleared out the validation error. You could use that button, for example, in any situation where, imagine you wanted to be able to close the form at this point by clicking OK or Cancel. OK definitely should not allow you to close the form, but Cancel should. So Cancel would have to clear this out, reset the error provider, and then we'd be able to close the form. So a cancel button in a situation like this where you have validation going on can be a lifesaver in making your form actually usable in the case that the user enters invalid data.